Hi, hello students. Welcome to Let's Understand Physics. Please like, share, comment and subscribe. If you have any particular topic doubt, you can comment me in the comment section so that I can make a video on it. So now we are discussing light reflection and refraction class 10 CBSE topic. Already object, image and mirror we have already learnt definitions. Now today in this video, image formation by a plane mirror we are going to learn. Now see here, if you have mirror, you have plane mirror. This plane mirror is used in generally houses. So all of us, when we are getting ready to go to school or to go to your parents to go to office anywhere, we generally look our face in the mirror which is in our house, that is plane mirror. So here plane means mirror, you have two surfaces, right? One is reflecting surface and the other one is silvered surface. So you have front side where you see, that side we call it as reflecting surface, and back side it will be coated silvered. So you have to draw like this when you are drawing mirror to differentiate between reflecting surface and the silver surface. Okay, I think all of you understood this. So in this reflecting surface, if you stand in front of this, you will get your image. So when you are seeing this image, you will be the object. Understood? Your image is seen in the mirror. Okay, now object definition, mirror definition and image definition we have already learned. Now just we'll see how image is formed. Okay, if anybody has any doubt, you can see my previous videos for definitions. Okay, now see here, I am taking object is point size, means very small object, just point. Sometimes you will have extended object as well. So if it is extended object also, for class 10 it is just one dimensional object, that means it has only height. Okay, what we consider object one dimension and it has only height. So you can either take an object which is extended with one dimension or point object. For image formation by a plane mirror, we'll do with both. Okay, now what we have learned, object means it is the point of intersection of incident rays. So if you are taking or telling anything is object, from there you have to take the incident rays. Okay, next image is formed. Now incident rays, you generally will have three types. Okay, generally how many incident rays you will have? Three types. What are the three types of incident rays? That means generally we will not have one light ray, isn't it? We'll generally have beam. So we have these three types of beams coming from object. Now first one is parallel beam of light. Parallel means you have learned in your maths, right? So what will be parallel? Like this. So these light rays are parallel to each other. So this beam we call it as parallel beam of light. Now next we will have second type of beam, convergent beam. Okay, convergent means these light rays will be meeting at a point. Convergence means meeting. Okay, like this, they all meet at a point. So this beam we call it as convergent beam. Remember this, very very important. Next, third one is divergent beam. Divergent means from one point all the light rays are moving into the different directions. So from here, let us take, this is the point, from here light rays will be moving into different directions. So this we call it as divergent beam. So we, by using all these three types of beams, we draw the image formation by the mirrors, either plane mirror or spherical mirrors. So now we are learning plane mirror. This is very very helpful, what type of beam we are considering. Okay, understood? Next, so I am just taking a mirror. So take this, what is this? Silvered surface. These terms are very very important. In the previous video we have already discussed, right? Terms we have to remember. This is silver surface and this is reflecting surface. Now in front of the reflecting surface we have to take the object. Okay, so what object I am taking? Point object, means the size of the object is just a point. Now I am taking the object here. Okay, so when you have to draw the ray diagram, you have to remember the types of the rays what we are considering, and then laws of reflection. Laws of reflection is valid in any type of surface, we have already learned, right? So laws of reflection also must be obeyed whatever ray you are considering. Okay, now I am just taking normal to this mirror. Okay, and I am considering a midpoint to the mirror. From there I will just draw the normal. What is normal also we have discussed. So in front of the reflecting surface, and the same way behind the reflecting surface also I have drawn the normal. When I have drawn the normal, on the normal I will consider either a point object or a extended object, anything, whatever you want you can consider. First I am considering point object. Now from object you have to take the what rays? Incident rays you have to take. Now consider incident ray which is falling on the mirror from object. Now from the laws of reflection, what do you know? You have to take a mirror, and wherever the ray is falling, there you have to draw the normal, isn't it? So when you draw the normal, you will get your reflected ray, means which, where you have to draw the reflected ray, you will understand, because the reflected ray must be drawn to the other side of the what? Normal. So that when you are learning more ray diagrams, you will not have confusion. This is the basic thing which you have to remember. First incident ray is drawn, then wherever the incident ray is touching the mirror, there what you have to draw? You have to draw the normal. Okay, red line also normal, that's why here again I am drawing normal with the red line. This is normal. Okay, now reflected ray to the other side of the normal I am showing with the different color. So this is the reflected ray. This is R, this is I, and this is N. Angles will be equal. Okay, now see here, is there any possibility to meet the incident ray and reflected ray? No, right? They don't meet. Now second ray, remember, to get image What is image? Point of intersection of reflected rays. So if you want to have intersection, minimum number of rays required are 2 rays. That's why minimum incident rays also must be 2, minimum reflected rays also must be 2. Understood? So we have drawn only one. I have I1 and R1 now. Now I2 and R2 also I have to take. Now this normal is there, right, for us? So this normal, whichever we have, that normal also is a ray, we can consider, because the object is here only. Now see here, from the laws of reflection we have learnt, when the light is falling on the mirror normally, incident ray, reflected ray and normal will be same, isn't it? Now I2, R2 also is same and N2 also is same. Now can you join these two reflecting rays in front of the mirror? You can extend to any length. Can you be able to join or not? Now see here, they are like divergent, means it is going this side, it is going this side. So there is no possibility of meeting in front of the mirror. So that what you have to do here, you have to extend the reflected rays behind the mirror. Now R1 I have extended, it is meeting this line here. In the same way R2 also I will extend, it is meeting here. Okay, so this is the point of intersection of reflecting rays. Understood? So these reflected rays are meeting here, and the point you can observe here, this is the point where they are meeting, and this is the size of the image as well. Okay, as you have taken point object, you have image also, point image. With extended also we will do once. Okay, I hope everybody understood this. Now see here, this is the plane mirror. So plane mirror means what? Reflecting surface will be plane. Plane means what? Straight. This is the reflecting surface which will be straight. Okay, now what we have to draw first? One object must be taken in front of the mirror. For that reference we are drawing a line which is normal to the mirror. Okay, now above the line I am just taking one extended object which has only one dimension, which is the height. This is the object. Okay, you have to show with the arrow mark. So from there you have to take the incident rays. Incident rays means you will just take the light from the object, those rays will fall on the mirror, so we call them as incident rays. Now see here, one ray what I am taking, I am considering this point and this point. Okay, so from here also I will take the rays, from here also I will take the rays. Actually you have to take from all the points. For simplification I am just taking top one point and down one point. Now see here, same diagram, instead of doing with one I am doing with 2 points. Before diagram we have drawn with 1, right? Now 2 points. Same diagram, no confusion. So now see here, with some angle I1 for the top point I1. Okay, now normal I am not drawing, you understood, right? It will go like this. This is R1. Now in the same way what I will draw is next one normal line. Okay, you will have I2 and R2. Understood? Now next see here, for bottom point also we will draw in the same way. Bottom point also. Okay, This is for bottom point I1 and R1. Okay, next normal. Normal is this thing only, this line what we have considered. So this is I2 and R2. I hope everybody understood. From top point I have taken 2 rays because minimum must be 2 from any point, and from down also I have taken 2 rays. Okay, now see here, you can extend it. Instead of extension you cannot converge, means they don't meet in the front of the mirror, means really they don't meet. That's why what we are doing, we are trying to extend it. So just extend R1. R1 is extended. Now R2 also I am extending. Okay, so they are meeting here. So for the top point you will have here. In the same way for bottom point also, let's see, extend this. See, this top point and bottom point separately you have to consider. Now for this, where do they meet? As we are not using scale and angles, I think this I have drawn correctly. The top one also, just a small change, it has gone up instead of this ray. Okay, now see here, one point is here and the other point is here. Okay, now if you are considering many points on the object, you will have those many points in these two, between these 2 points you will have like this. If you join them like this, you will get image. So what is this here now? Image. Okay, in class 6 itself you have learned. For example, if you place in front of a plane mirror a chessboard, if you place the object on some third row, you will have image formed on the same row. Image will be formed on the same third row, so that you can say object distance will be equal to image distance. Now what is this object distance? How to find? Object distance is the distance from the mirror to the object. What is object distance? If this is the object, from mirror to the object, whatever distance you have, that we call it as object distance. Remember, the distances must be always measured from the mirror. Okay, so this is denoted with letter U, and here you have image formed, isn't it? Now the distance between mirror and the image, we call it as image distance V. Okay, so U is equal to V. Now size also will be same. Now HO, height of object, will be equal to height of image. Okay, so the same experiment you can do. You just color one box like this in front of the mirror, the same box completely colored in the mirror. So whatever object you have placed in front of the mirror, the same will be seen in the mirror, behind the mirror, with the same size. Okay, and next you can observe on your own. If you just raise your right hand, you will see left hand is raised. That means not your left hand in the image, whatever rise, if it is in right side, but in the mirror when you see, it will be in the left side. Okay, so this change of side, what we call is lateral inversion. So remember, lateral means side. So lateral inversion means what? Sides are exchanged, or sides are inverted, and the image is formed by intersection of extended rays. So we call this image as virtual image. What do we call? Virtual image. And the image is erect. That means it will be straight. How you are standing, you will see your image also in the same way standing. Okay, you can take just one bottle, keep it in front of the mirror. However you kept the bottle in front of the mirror, the same way you can see in the image also straight. Understood? So cap will be up if you place cap upwards. If you place cap downwards, you can see the cap downwards. Okay, so the image are virtual image and erect. Okay, I think all of you understood the characteristics. We'll just brief it. First one is image is virtual and erect. Why virtual also is discussed, and what is erect also discussed. And second one is same size of the image as object. Image size is equal to object size. Next, third one. What is third one? Size. Sometimes height also you can write, no problem. Next, distance. Very, very important. Distance of object is equal to distance of the image next, lateral inversion. In 1 mark they can ask what is lateral inversion as well. So remember, lateral means side, inversion means reversing. So sides are reversed, so we call it as lateral inversion. Means the phenomenon of left appearing as right and right appearing as left in the mirror is called lateral inversion. Okay, not just sides reversing. Means, to understand, I have told, if they have asked you to write the definition, what do you write? The phenomenon of left appearing as right and right appearing as left in the mirror is known as lateral inversion. And what are the uses of lateral inversion? Lateral inversion, ambulance is written in the on the ambulance with lateral inversion, isn't it? So that in your rear view mirror you can see this ambulance as the normal spelling. Otherwise, ambulance also is seen in the mirror in the lateral inversion, then they will have confusion whether it is ambulance or not. That is the reason on the ambulances generally it is written in the lateral inverted form. Okay, I hope all of you understood this. Okay, very, very important, these concepts. On the lateral inversion basis also you will have questions, so we'll see them in the next video. Thank you, and please like, share and subscribe to Let's Understand Physics.